Welcome back to Adventures in Python. If you're new to us, welcome. This week we will continue with our investigations in Python using Turtle. I think that I may continue for one further session with Turtle after this because the Turtle gives us instant feedback from our coding. Oh, and it's fun. So, on with lesson 3. Last time we were creating shapes in Turtle, and today we will continue with creating shapes. But this time we will look at some of the attributes that we can assign to the shapes, like colour for example. Take a look at the code here. This code is the same as the spiral code from last week. However, you can see that the spiral is now green. We have used the .pen color attribute. Note that just like a string, the colour has to be in double quotes. There are many pre-programmed named colours that you can select, and also if you know the RGB or hex value for web colours, they work too. But just typing the standard spectrum colour names will work, and you can also add the word light to the front, so blue becomes light blue or green becomes light green, but write them all as one word. Just experiment with your colour choices. I found that now that I could add colour, I wanted to add more. So in the first instance I simply copied and pasted the relevant lines of code below and changed my colour choices in the .pen color attribute. Doing this gave me a wonderful effect with the four-sided shape being coloured in order by my 3 colour choices. It is clear that although this solution works, it would quickly become a pain to write lots of code like that. I'm learning that coding tends towards simplification. In the books they suggest that instead of lots of code, we should make lists and use the code to refer to the list. And the simplest way to do this is to make a variable. In my case here I've made the variable col, and then I write my list inside the square brackets. Note how the list is written as strings, separated by commas and enclosed by square brackets, and this distinction is really important. Now, in the code to build the shape, I have amended the t.pen color argument. Instead of just stating the required color as I did before, I now call the col variable for colors. And inside the square brackets there is this new formula, x%4. This needs some explaining. The x still represents where in the repeat of the range Turtle currently is. In other words, if this is the second time through the loop, Turtle will be on the second loop of the range and will be moving forward 1 unit. Remember, Python starts counting at 0. The percent sign is the mod operator or modulo. This is used to help Python count through my colour list and select a colour in sequence each time it runs through the repeat. The 4 represents the number of colours in the list, so if I had 6 colours in the list, the number 4 would have to be changed to 6. All well and good so far, but how does the mod operation work? It is a division operation that delivers whole remainders, just like we used to do before we learned the long division algorithm to give us a decimal answer. In other words, using 6 mod 4, or 6 divided by 4, we get 1 remainder 2 as an answer and not 1.5 as you would with long division. It is the remainder that Python uses to count its way through the list of colours. In our list we have green, red, yellow and gold. So if x equals 6, then 6 mod 4, or 6 divided by 4, would give us an answer 2. As I said before, that would be the third item in the list, or yellow. 7 mod 4 would return 3, or gold in our list. 8 mod 4 would give us a remainder of 0. So green is the answer. It seems odd at first, but once you understand it, it is a simple mathematical answer to creating a logical sequence. I like it. And who said that division was boring? Once we understand what is happening, mod becomes a very powerful tool for us to use. And here is my end result. One thing that I have noticed is the time Turtle takes to execute the instructions given to it. So let's speed that up a little bit. In the new line of code here, you can see that I've introduced a new argument, t.speed. The number in the brackets set the speed, I believe in percent, so now my program will run twice as fast as before. Be careful though. Sometimes it is good to see how your program is behaving, and watching it evolve slowly can be beneficial, so use this with caution. Whilst we are focusing on enhancements to the code, you can see in this variant of my code I've added yet another argument, t-dot. This argument tells Turtle to put a dot at the end of each line before continuing with the remainder of the script. The number denotes the size of the dot, and the string tells Turtle the colour I want the dot to be. If we experiment with this, we can get some really interesting results. You can see here how I have played with the code to create this star effect from the Turtle code. In my exploring with code this week, I have found the t-dot argument fun, but it got me wondering about how to use this feature. I am still thinking about it, but some ideas for a game challenge are emerging. Then I found a further argument, t-dot stamp, and as you will see on the following slide, it can create some more interesting ideas. As you can see on this slide, there is a bit of a variation in the syntax for creating a new window for Turtle to play in. But what you see here is that the t-dot stamp argument stamps whatever is declared in the t-dot shape argument. Note also that t-dot stamp acts rather like a t-dot pen down action. The whole block of code starts with t-dot pen up, and Turtle will only create a mark when the t-dot stamp argument is called. The variable size is initially set at 20, but once in the code it grows at size plus 3 on each iteration, and it is this argument that is put into the forward argument, which is how the gaps between the stamps get bigger. I think we can have a lot of fun with this set of code, especially with the t-dot and t-dot shape arguments. And so it is these two arguments that will form the basis of this week's challenge. I'm pretty sure that all the information needed for success has been covered in this week's lesson. So good luck! This week's challenge is really a cascade of challenges. So let's get on with it. The first one is, can you make a clock face? By that I mean, can you create a program that uses the t-dot stamp and t-dot pen up arguments to create the 12-hour markers on a clock face that are indicated by your chosen stamp shape? The second challenge is a spiral. Using the spiral code from the last slide, can you modify it so that the triangles are dots? Having done that, can you modify the code again so that the dots are different colours? Having done that, can you do the spiral again so that the dots are different colours and grow in size on each stamp? I think the size variable might help you here. And finally, for double points, if you have successfully written that code to create a spiral of dots that are different colours and they grow in size, can you get the code to reverse such that the largest dot is created first on the outside of the spiral and the smallest last in the centre, with the end result being that it looks as though the biggest dot is on the bottom of the stack and the smaller ones are laid on top in order of size right to the centre. So, pick a challenge. Do all of them. I've yet to work out the answers myself, so let's try and crack them together. Use the comments below to share your results, encourage your friends to subscribe and join the community, and we will only get better if we keep practicing. So good luck!